Good morning, ladies and gentlemen. So I am starting out with 7.2 PowerPoint today. So two things you need to have with you in order to look over this concept of oxidation numbers. You will need your packet. In your packet, if you remember, I have assigned the charges to your groups of elements, right? So you'll need that packet out for this lesson. Also in that packet, along with the periodic table with those charges written in red pen, you are also going to need the electronegativity chart that is also in your packet. Okay, so take a few minutes, get that packet together. We are doing 5 lines for 5 points today, so make sure that you are taking your 5 lines of notes for your points. You will submit that in the classwork tab for me to review. All right, whether you submit the Google Doc or you take a picture of your handwritten notes, either one works for me. Okay, so this idea that we're discussing today is oxidation numbers. So we've already kind of talked about how to name these polyatomic ions. How do we name these compounds? If you remember, right, section 1 was all about naming the compounds that were the just binary type 1, which was you named the metal, and then you named the nonmetal. So you said your cation, then your anion ending in "ide," for example, sodium chloride. Then we talked about the transition metals, which was binary type 2. That was, for example, copper to chloride. Okay, copper to chloride. Remember, with any transition metal, we had to add a Roman numeral for that type of compound. And that's for transition metals, which is a type 2 binary. Then you get to type 3, which is your covalent, right? Binary covalent molecules, type 3, and that's where you used your prefixes, right? So we had dinitrogen monoxide. For water, it was dihydrogen monoxide, right? So that is the chemical name for these compounds. Now, to help us with that, we move on to 7.2, which is literally how are these arrangements of atoms indicative of the name, right? So when we're looking at how to name these compounds, we can also use what's called these oxidation numbers or oxidation states. Pretty much it's kind of a summary of the arrangement of atoms per element. So that's what we're going to look off of, but we have some general rules for those that we have to follow, and then assign that each element a number based on the arrangement of the atoms. Okay, so I've got the first 3 rules here, right? So the charge of the atom would have in a molecule or an ionic compound if electrons were completely transferred. Now we know they can sometimes are only partially transferred because sometimes they are shared, right? Especially with those covalent compounds, those nonmetals, right? A nonmetal plus a nonmetal, they share those electrons. So we have some different situations, different scenarios here. So the first rule for naming or assigning these oxidation numbers is that these pure elements, right, in an uncombined state, so they have not bonded with very much yet, have an oxidation number of 0, right? So if I have just sodium, just beryllium, just potassium, if I have H2, O2, my diatomic molecules, right? Remember that as my nitrogen, my oxygen, my hydrogen, any of those halogens, group 17, those, for the most part, will have an oxidation number of 0. Okay, and this starts on 7.2. And then number 2, in a monoatomic ion, right, the oxidation number is equal to the charge of the ion. So in this case, the charges that I have written on the front page of your packet here, right, are the numbers. I wrote it in red ink here for you. So pretty much remember, right, if group 1, they have 1 extra electron in their valence shell, they want rid of it, right? So they are going to have a charge of +1. So for example here, lithium, if you look at the screen, lithium here with a positive charge, right? A plus 1 charge, because it has one extra electron, is just going to have a positive 1 oxidation state. All right. Then we get to iron. If iron, remember, if the Roman numeral is stated, or if the charge of the cation is stated, that's the oxidation number. So in this case, for iron, if it's stated here that it's Fe3 plus or a plus 3, we know that that oxidation number is going to be a plus 3. Same thing with oxygen. Oxygen, if you look, right, group oxygen is in group 16 over here, meaning it has 6 valence electrons. It needs 2 more to reach that octet rule. If you remember, the octet rule is it wants to get to 8. Okay, it needs 8 valence electrons to become stable. It has 6, so it needs 2 more. So that's why it has a -2 charge here. It needs 2 more electrons. And as you know, each electron is 1 negative charge. Number 3, the oxidation number of oxygen is usually -2. However, if you have any of the peroxides, right, very rarely, but usually if you have a peroxide, for example, H2O2, right, and just O2, that is going to have a -1 charge, okay, because it is paired with the hydrogen and it's trying to balance out that hydrogen. So if you have it in any of the peroxides, so for example, in the O2 state, it will have a -1 charge. Otherwise, if it is not in that O2 state, as a diatomic molecule, it will just have an oxidation number of -2. Then we have to have all these equal to 0, just like when we were balancing, right, the charges to get the formula, to get that chemical formula. Remember, on all of those types, binary type 1, binary type 2, binary type 3, to get the formula, we had to balance the charges, and we had to get them to equal 0, and it's the same thing here, right? The sum of the oxidation numbers of all the atoms in a neutral compound have to equal 0. You're trying to get them to add up to equal the number 0. Number 5, the oxidation number of hydrogen is +1, except when it is bonded to metals in a binary compound. So yet again, it's going to be a +1, except for when it's bonded to another metal, okay? Because if it's bonded to another metal, it's going to act like a nonmetal, right? So in that case, the oxidation number is -1. Remember, hydrogen is a tricky one, okay? It's an exception to a lot of the rules. It is a nonmetal, but it behaves as a metal. So be careful of that one, because if it's with a nonmetal, let me go back. If it's with a nonmetal, for example, down here, it's with a peroxide, and it's acting on that, right, as though it were the metal. So it's going to make that, this hydrogen, each hydrogen will have, in this case, the peroxide will have a +1 hydrogen charge to equal out the -1 of the oxygen. So if I have 2 hydrogens and 2 oxygens, I really have +2 plus a -2, which equals 0. Okay, otherwise, it's going to act, if it's bonded to a metal, it will act as if it is the nonmetal, and it will be a -1 oxidation state. Okay, an example of that would be like, let me give you an example. Let's just do aluminum hydride, right? So aluminum and the hydride, that is going to act, the aluminum is going to act as your metal, the hydrogen is going to act as your nonmetal, okay? So just an example there. Number 6, group 1 metals, right? Group 1, right here on your periodic table, group 1 is a +1 charge, group 2 +2, right? And fluorine, which is group 17, has a -1 charge. Those are already stated on this periodic table. I wrote them in at the very top in red pen. Okay, fluorine is going to be a -1 anyway because it is a halogen. It's group 17. Group 17 has 7 valence electrons. It needs 1 more to get to 8 to fill that octet rule. Remember, they all want 8. Fluorine has 7. It wants 1 more. It needs 1 more -1 charge. It needs 1 more electron to get to 8. So, of course, fluorine has a -1 charge. And number 7, the sum of the oxidation numbers of all the polyatomic ions are equal to the charge on the ion, just like we've talked about before. Calcium, right? Calcium is over here going to be your +2 charge because it's in group 2, right? Hydrogen is going to usually, or lithium or sodium is going to have a +1 charge because it's in group 1. Group 13 is going to have that +3. Group 14 is going to have a +4, right? 15 is going to have a -3, 16 -2, 17 -1, and of course your wonderful noble gases here, group 18, have that 0, okay? They're already filling that octet rule there. Group 18 has 8 valence electrons. They don't want to bond with anything else. So let's run through some examples here, okay? So in this case, the oxidation number, right? Say I have, anybody know the answer to this one? What we call this compound, right? We have 2 nonmetals, so it is a binary type 3, so you should be using your prefixes, right? Remember, I do not start with mono, so this one is iodine, right? Heptafluoride, okay? So iodine heptafluoride is the answer to that one. So in this case, fluorine is going to have a -1 charge because it's in group 17. I do not know what iodine has, okay? In this case, iodine would be acting as my cation, so I know here that fluorine is going to have a -1 charge, so I have -7, okay? I have a -7. So what's going to equal out that -7 to equal 0? Right? +7. So here I have it. If fluorine, I know fluorine because I go back to the rules. I go back to the rules and it says fluorine equals a -1 charge. Then I plug it in. If I have 7 fluorines, what does my 1 iodine have to be? Right? I have to equal it out to 0. And that's that question mark. So what goes here is that question mark in this equation to equal 0, and you should say +7. So I know that the oxidation number for iodine is +7. The oxidation number for each one of those fluorines is a -1, and that will equal out that compound to 0. All right, here we have another one. This is a polyatomic ion. The polyatomic ions, I do not make you memorize the names, okay? That is on the back here, if you'd like to look that one up. It is on the back side of your periodic table in your packet. You can look through here to name it, right? I do not make you memorize those. So let's go through this. What do I do know, right? What do I know? So I need to start out with probably either my sodium or my oxygen because I still don't know the charge of that iodine in this compound, right? So, but I do know oxygen is going to be a -2 charge. Okay, go back to your rules, right? Rules 1 through 7. I do know that oxygen is going to be a -2 charge because it is not with a peroxide. So right there, I know I have at least have a +6. Sodium could be a +1, I'm assuming in this situation because it is not by itself. So I'm going to assume that sodium is a +1 based on the fact that I'm going off the cation and the charge of the cation here. So if you look, sodium is in group 1, so I'm going to give it a +1 charge. Okay, so here at the top I have sodium is +1, oxygen is my -2. I have 3 atoms of oxygen here. So 3 times the -2 gives me -6. Plus I only have 1 sodium, so I'm plussing 1, right? So that's a -5 charge or oxidation number total. And so in this case, I have to cancel out, say, okay, if I have a -5, what gets me to 0? Okay. And in that case, right, -5 plus a 5 oxidation number gets me to 0. So I know that iodine has to be a +5 oxidation number. Okay, if you have any questions, you just email me any and all questions that you may have. All right, next one is another polyatomic ion. Here I've got potassium. I've got 2 atoms of potassium, 2 atoms of chromium, and 7 oxygen atoms. Guess where I'm going to start again? I am going to start with the oxygen. I know it is not with the peroxide. So I know that that oxygen has a -2 oxidation state. There are 7 of them. Whew, right? Talk about the math. So 2 times 7, I know that's going to automatically put me as a -14. Okay. If I go off of the charge of potassium, potassium is +1. There's 2 of those. So I'm going to have a +2 charge. So -14 plus 2 gives me -12. So I know that those 2 chromiums have to add up to -12, right? So if I take -12 divided by 2, or just 12 divided by 2, because since this is a negative, it's got to be a positive to get me to equal 0. So 12 divided by 2 gives me 6. So I know that each one of those chromiums has to have an oxidation number of 6, right? So I start out with my oxygen. It was -2. Go to the cation, your potassium. Potassium is a +1 because it's in group 1. And then I multiply, right? I got -14. I added the +2 here. That got me to -12. And then I divided by 2 to get 6 because there are 2 chromium atoms here. And I know it has to be a plus charge because to get that -12 to balance to a 0, then each chromium atom has to be a positive, right? Positives have to counterbalance the negatives there. All right, now we're working on what if it's still an ion, right? This whole compound, what happens if it's still an ion? It still has a positive or negative charge, meaning it's either got an extra electron or it's lost an electron, right? And so that's what we're working with here because there's some of those on your section review for your homework tonight. So in this case, right, I've got hydrogen, 1 atom of hydrogen, 1 atom of carbon, 3 atoms of oxygen, and it is an overall negative charge, right? So thinking about with ions, right? If it's positive, I've lost an electron. If it's negative, I've gained an electron, right? Back from physical science freshman year. So remember those ions. Okay, sorry about that. So in this case, yet again, I'm starting with my oxygen because I know oxygen is only a -1 charge if it's with the peroxides. So I can go ahead and assign that oxygen as a -2 charge. There are 3 oxygens, so I know -2 times 3 is going to give me a -6 oxidation state or charge. Then my hydrogen, since it's with a bunch of nonmetals, is going to act as if it's a metal. So that hydrogen, being in group 1, right, tricky little booger, being in group 1, it is going to be a +1 charge. So if I'm at -6 plus I add 1, right, that puts me at, anybody know? -5, okay? So I'm now at a -5, but since there is that pesky negative number because it's an ionic compound, right? It's still an ion, then we are looking at the fact that that -1 charge is still there. So I'm not equaling 0 anymore. I'm equaling a -1. So how do I get to a -5 to equal out to a -1? And of course, you should say, okay, well, if I'm clear over here on the scale, -5, how do I bring it back to -1? Well, I need +4, right? I have to add a +4 to get it to equal -1 on that scale. Okay. So same thing, if it's positive, right? If there was a plus sign here instead of a negative, then this would equal a +1, and you would have to get it to a +1 and not a -1. Okay. All right, so now for your homework. So first of all, I want you to go ahead, get into your PDF of the chapter, and on page 234 of that PDF, there's a section called Using Oxidation Numbers for Formulas and Names. If you have not read that already, please take a few minutes, say 5 minutes for the rest of class, to read that section, look at that table, look at your examples, okay? Then start on section review. You are doing 7.2 section review. You are only doing number 1, not number 2. So number 1, you are doing A through K. A through G are neutral, so those equal 0. H through K, they either equal -1, -2, or -3. Okay, so just kind of a heads up there. Please specify, help each other out if needed. If you still can't figure this out, I will go over this again tomorrow in class. I will help you walk through some of these. The bell's just like me today, I guess. We will walk through some of these, but if you're needing immediate feedback, just send me an email, okay? And I will answer those in an email at whenever I'm free at this point. So otherwise, you can stay after school today or come see me during homeroom. All right. Have a great day, guys.